All right, so let's get started. My name is Giovane. This is work I did together with some colleagues at SIDN Labs in the University of Twente. Fragmentation, truncation, and timeouts on DNS. Let's see this. So as we all know, the DNS is one of the core protocols on the internet. Every visit to a web page requires DNS queries. You cannot get to that without DNS queries. And DNS is actually an application protocol that uses both an UDP and TCP as a transport protocol. UDP is used by most queries, and it's super fast because you can get a response within one RTT. And DNS can also use TCP in case of very large messages like some transfers and when the UDP fails it. So it's a fallback option. But servers should support both. And the problem occurs on DNS when you're trying to send very large responses using UDP. Vanilla UDP, on DNS, you can send up to 512 bytes responses. UDP has no problem. And the problem starts when you use UDP with an extension that's called eDNS0, which allows the resolver to tell the client to tell the server, the authoritative server, say, hey, I can handle large messages up to this size. But the problem is that the client can tell that, but the client has no actually awareness of what the network can handle. The network, what I mean, between the client and the server. When in this case, even if a server sends a response which is very to the client, which may be okay for the client, but not for the network, what can happen is the network may not be able to transmit that, and the packets can be fragmented or discarded silently, and the client may never notice that, and that can lead to unreachability. And if the response is too large for the server to send to the client, what the server can do is truncate it and flag that response with a truncation bit. So when a client gets an answer, the client can ask back with TCP. But between fragmentation, unreachability, and truncation, what we really want to answer in this paper, we're looking for to answer is how big is this of a problem in DNS in production in the real world? And what we do, we analyze traffic from the CCTLD of the Netherlands, DNL, 3 months of data, and this is 164 billion queries and 164 billion responses as well, from 3 million unique IP addresses, and from 46,000 autonomous systems. And we investigate mostly 4 research questions, which I'm going to get into that right now. So the first one we wanted to answer is like, how come our large responses? I mean, especially to UDP, because the problem lies when you have large responses with UDP. And we plot for 2019 and 20, you can check the paper for the rest of the graphs. This is V4, this is V6. The CDFs, and what the CDF shows is for each server protocol here for UDP, what we see that most of the responses fall within this area. It's 99.99% of the responses over UDP that are actually smaller than 1232 bytes. So most of the responses are very small, which means they are safe, which means that they run very little risk of fragmentation. And it's not only DNL. Google Public DNS also reported like that 99.7% of the responses are smaller than 1232 bytes. We see the similar things for IPv6 as well. So in short, large responses are not very common on DNS. And one thing you can also answer with our vantage point is how often server-side fragmentation occurs. So what we did, we analyzed the responses that our server has sent, and we found that out of 2.2 billion daily queries, fewer than 10,000 queries are actually fragmented. So it's a very rare event to observe that on DNS. So it rarely occurs. But the fragmentation for IPv4 can also happen in the network. It doesn't happen for V6 because V6 doesn't allow in-network fragmentation. But I checked the paper, but what we found is 7% of the large responses, not using our vantage point, but using Red Atlas, timeout. It's similar to values to previous reports. And other thing they wanted to know, it's like, hey, how come DNS truncation occurs? And as I said, truncation occurs when result on a client side that can handle a large response, but the server cannot send up to that limit. So the server say, hey, you want me to send an answer which is 3,000 bytes, but I cannot because I'm bounded to 2,000. So I'm gonna send whatever I can and truncate it. And you better ask with TCP if you want to know everything. And analyzing these queries, this is all the entire data set that we analyze. Depending on where you analyze, most of the queries are UDP, and very few of the UDP ones are actually truncated, from roughly 3 to 7%. So not that many are truncated, but a certain number are truncated, from 2 to 7. And when truncation occurs, the service should actually follow up with a new query that should be sent using TCP, because the server is pretty much just saying, hey, I can send the entire answer, query me with TCP, and I'll send you everything. And we did some calculations on the paper, and it turned out that 79 to 85% of the resolvers actually follow back with TCP. We have some reasons why there's other 15 to 20% are missing, but check the paper. And another thing we have in the paper, it's actually the DNS Flag Day. So some members of the DNS community, they propose operators to set this limit of 1232 bytes in both authoritative server sides and resolvers to not send or ask responses that are larger than that, and we use in UDP. And that could be we can actually measure that using our vantage point. We can analyze what resolvers are actually advertising when it comes to our authoritative name servers. And what we did a CDF for the entire month of July that we observed in October, and July was actually the baseline. It was the month before the flag day, and October is the month right after it. So what we see that both lines overlap here of the buffer size that they advertise. Most resolvers are still doing like 4K, which was the default value for bind. And we don't see many of them doing 1232 here. You can check on the paper for more details. But some networks actually changed that, but you can check in the paper. So in summary, are DNS responses fall into bits? Well, we found that most responses are actually small, so they run very little risk of fragmentation. And we also found the server-side fragmentation is minimal. And 2 to 7% of the UDP responses are truncated, and roughly 80% of them are followed by a TCP query. And the uptake for the DNS Flag Day 2020 was not very noticeable yet, but probably can measure that for a little longer and see if we found different trends. And with that, I end this presentation and open to questions.